Welcome back. It's CTF time, and therefore I pulled out my black hoodie and we are going to take a look at this very hard reverse engineering challenge. You can find this over here, and I highly encourage you to register yourself on this website and also take a look at the other challenges. Maybe after this course, because then I have weaponized you with all the skills and knowledge on how to solve them. In my case, I already did this, I guess, 2 years ago. And this is not a flex, this is something you might expect from me, right? Absolutely, and I'm glad that I didn't disappoint you right there. The challenge we are going to solve with the flow graph is the UPOS challenge. And this is also the challenge with the highest amount of points and the least amount of solvers. So this is definitely the hardest challenge in this whole box right there. But what makes this challenge that hard? It all did start with the APK itself. My first attempt was, okay, let's try decompile this application and get the Java sources out of this. I opened up my terminal and neither JADX nor dex2jar was able to compile or decompile those classes.dex files. Therefore, I didn't have a Java source code right there. And this was the time where I was looking for a different decompiler than JADX and dex2jar, and I found one, the DAD, within the Androgard tool. And finally, Androgard was able to decompile this application, and I was like, great, maybe this is the hardest part in this challenge, to decompile this application and get back those sources. Well, I was completely wrong about this, because after decompiling this application, I did end up with a bunch of methods. There weren't that many, I guess 3 or 4, but one method was really huge. And this method did look like this, multiplied by 20 times. So this method was full of branch instruction. We get our input, we pass it into a function, and then we got tons of branch instruction. And you have to think of this. One leads to this and one leads to this, and then we've got these and then over these, and this multiplied by 20. And finally, in between all those branch instructions, there's this one single solution which we have to reach. But there were some little sneaky branch instruction in there. It's not like that always the true path is the correct one. Sometimes there were checks like, does this flag contain the following value, for example, UPOS? And you were like, oh, okay, maybe UPOS has to be within our input. And you followed the correct branch instruction, but it was the left one, the false branch instruction, and things like this. I guess there were also some anti-debug mechanism there. If you hooked up Frida and tried some runtime analysis, the application behaved in a different way. So this one was ridiculous hard. And after staring at this Java source code, I was like, okay, it's not possible for me to solve this challenge by staring at this Java source code and figure out which branch instruction leads to the final solution. The solution itself, by the way, was not really hard to identify because there was this really long hash, and your input gets modified during all those branch instructions. Afterwards, the input gets hashed and those two values get compared. So where we have to go, this was pretty clear. But how do we get there? Absolutely not. And therefore I figured out, okay, for me the only way to solve this is creating a flow graph. And you will see the benefit afterwards if you have this, and we can then eliminate all those sneaky and wrong branch instructions, and afterwards we end up with a clean way. This isn't that easy as it sounds, because this takes time. I guess it did take over 1 hour to eliminate all those wrong branch instructions. But these are the two main keys, patience and time, if you reverse engineer Android applications. Alrighty. The last thing I want to mention is the flow graph contains only Smiley instruction. So we do not get our Java source code in this flow graph, we do get our Smiley source code in there. For me at this time this was no problem because I was pretty familiar with the Smiley. But if you want to solve this challenge afterwards, you might have to wait until we have finished the next chapter where we learn Smiley if you're not familiar with this. Of course, if you already know Smiley, then feel free to go ahead with this approach and try solving this challenge. And let me know about this if you could solve this with the flow graph. But please don't ask for a solution. I'm not going to provide you the solution for this, okay? The last funny thing about this challenge was, after I have solved this, I talked with the author about this. And the author did also mention that he did not expect that a decompiler is able to decompile all those Java sources. But even by having these Java sources, I did not get any benefit out of this, because the flow graph itself, which was the main concept in solving this challenge for me, was written or has this instruction in Smiley. So even if I did decompile this application, I did not get any advantage. So this was pretty ridiculous for me. But it's super nice to see that different decompilers give different results. So if you struggle with the decompiler, try different tooling. For example, Dex2Char, JADX, and now also AndroGuard. Maybe one of them is able to solve it, or maybe one does better than the other. So yeah, please try different tools. Maybe one of them is able to solve this task. All right. Next, we are going to have a look in this challenge. We are going to download, install it, and then we take it apart. But only until we get to the point where we have created this flow graph, because I do not want to spoiler any further. Okay, here we are now at our Ubuntu VM, and if you want to download this challenge, then please go to this website. This is the website of the author, and you can find those challenges over here. By the way, the author also put in some amazing slides which you can find over here. So definitely also have a look into this one if you are interested in a certain topic, which is super nice from the author. Okay, you can find the challenges here, and then you have register on this website with an email account, and then you can finally download this APK file. I'm not able to provide you directly this APK file because I would circumvent this whole mechanism of the author, and this is something I don't want to do. The author did put a lot of work into those challenges, and it would be absolutely fair if we at least leave a registration for his website over here. All right? Okay, you can pause this video and yeah, register your account over there and download this upus.apk file, and then you can move on with the video where I explain on how to create all the stuff, or you can just lean back and watch me doing this. So I'm going to close this one, and yeah, I already download this file. It's within the downloads directory. And here we have it. I copy paste it and we create a new directory over here. And we name this Upus challenge very hard. Alrighty, let's start decompiling this Android application with our Dex2Char approach. Let's see how good this goes. No, I don't want to update right now. And therefore we have to unzip this to get those classes.dex file. Here we have them. We've got two. So I would assume our interesting source code is over here in classes2.dex. Dex2Char. And here we have our classes2.dex char now. If we run jdgui, we can see we have a code over here. Let's figure it out. Yes, Dex2Char is still not able to decompile all those methods, as we can see right here. So this one is the check flag method, and we can see we only got this Java bytecode over here. So we cannot do anything with this right now, okay? Maybe not okay, but we do not have a choice. All right, let's try JADX. JDX GUI on those Upus APK. And yes, JDX GUI seems not to be able to decompile anything, but this is an error which is regarding to using the wrong Java version. So in the last video we have changed the Java version. Let's check this real quick. Yes, we've got Java version 8 already installed, or not installed, already in use. We have to switch back to Java 11 if we want to use JDX GUI. All right. So sudo update alternatives --config Java. Yes, and then I select version 0 to use the Java 11. And we also have to repeat this for the Java compiler. Also 0, okay. Now it should be fine. Yes, now we are back on Java version 11. Let's try this again. Yes, okay, this is the window which we should at least get. So if you get a blank window over there, then it's regarding to an outdated Java version. It's annoying, I know, but unfortunately we have to deal with this. Okay, let's see if JDX is doing this. So we can see also JDX is not able to decompile this code. All right. Now let's try AndroGuard. AndroGuard --help. And here we have this decompile. AndroGuard decompile --help. Yes, and here we have now the options of unregard decompile. We can see, for example, we can define an output directory that contains then our Java source code. So unregard is decompiling those classes.dex with the DAD decompiler, which is also mentioned here, and creates those single Java class files in this output directory. And this one we will take a look in a few seconds, because this is now the flow graph we can create with the decompiled code together. Okay, but for now, let's only try decompiling this application. Unregard decompile, and then upos, and we have to provide an output directory. I simply named this out because out is not available over here. So we didn't create this directory yet, but if we provide it as a parameter, then unregard is going to create it and stores all this function and decompiled code into this. Alrighty. This might now take some time because it's a lot of stuff going on there, and I will come back if this decompilation process has been finished. Now the decompilation process has been finished, and let's figure out what we've got here. Okay, I'm going to open this in a file browser, then it's easier to see. This seems to be our main package names. We've got Android, Android X, and COM. So I would assume our code is within COM because this sounds like the developer path. Mobisec, upos, and there we go. We've got Java files, but we do not know how good they are right now. We've got also this directory, and here we've got some HE files. We will take a look into this later on. Okay, here we have now the flagcheck Java file. Let's try opening this. I open this in the terminal over here, then we are in this directory, and I use gedit, for example, fc Java. Okay, and here we can see this looks like, yes, this is Java code, nice. So unregard is able to decompile this file. We have this check flag method over here, and this is all Java code right now, and you can see all those branch instruction already and the sneaky traps. So our input might have to start with Mobisec or might not. We do not know right now. You have to go down the whole rabbit hole, and you can see there's a lot of stuff going on. If we scroll through all these instructions, and here we can see this one is the final hash that our input gets hashed and compared against afterwards. But this is not the end right here, so I guess, yes, there's a lot of stuff underneath this. So there are some jump instruction upwards and things like this. You can try solving this with this Java source code, but you would go absolutely crazy. Therefore, we are going to create a flow graph. But first, let's install and run this application and have a quick look in how this looks like. The view itself is pretty clean and easy, and but it's good to know what we have to deal with. So therefore, we go into our apps directory, upos challenge, and we are going to make our connection via ADB. Alrighty, then we do ADB install upos.abk, and we are also going to get the screen over here. Here we've got this upos application.